A review. Okay, so the purpose is that this girl is throwing the stone at an initial velocity of 12 meters per second. What we know is that she is 20 meters above the river on the bridge, okay, and that the piece of wood is 13 meters away from her, but away horizontally, okay? How do I know that that is horizontally? Because that distance is measured like this, okay? And this is the horizontal axis. Why? Because you see over there, that is the x, okay? So the problem is giving me a target distance of 13 meters. Now the question is she going to hit the block? So the analysis that I have to do is what is actually the problem asking me to find. As Emma and Angie were saying, okay, we're going to do a comparison. A comparison on what the stone really covers when she throws it and the target. The target is 13 meters away. So I need to compare. Let's see. Let's write the data. Let's write the data. The problem is giving me an initial velocity that is 12 meters over second. It's giving me an angle, a downward angle of 45 degrees. So I can just write that is below the x-axis. That's important, but not so important in the end. But I'm going to write it as a given, okay? Now, if the stone is thrown from a height of 20 meters, okay? So, this is important, okay? The initial position in y is telling you that is 20 meters above the river. Okay? Now, question. What is my final position vertically? What is going to be my final position of the stone vertically?
13 meters.
Negative 20.
Negative 20.
Take a look here. It is very confusing, and that's why you can either say, take a look. Is that here the problem is giving you the sketch already, and that's huge advantage. The sketch is telling you that the initial position is 0 for y and 0 for x. And this is what we know as the launching point. Okay? So, the initial velocity is actually 0 meters, okay? But it's located above the river. Now, the final position, as you said, is right here. But I'm measuring the position vertically. And vertically, this is negative 20 meters. Because it's at a ground level for that saying, okay? Or it's 20 meters below the initial position. So the final position in y is going to be negative 20. I got it from the sketch. Not from the word problem. Now, it says the block is 13 meters from the bridge. So here I'm not going to write delta x or x. Here I'm just going to write my target, okay?
Target is like distance, right?
My target is wait, how Vamos a ver. Yo tiro un dardo.
The point of impact.
Objetivo.
The point where the object is going to fall.
Hit. Yes. The target is. Okay, I'm gonna draw it because I forgot the name in Spanish. Okay.
It's like the objetivo you want to.
Exactly. Yes. I forgot the name. But it has a name in Spanish. I forgot. I totally forgot.
El blanco.
El blanco. Thank you so much. I totally forgot. Thank you. El target sería como el blanco, like the place where I want to hit. Okay. Okay. So I want to know if he is going to hit the block. How? Comparing with delta x. I mean, I want to know what really happens. Okay. My ideal is that I reach 13 meters. But I don't know if the stone is going to surpass the 13 meters and is going to reach, for example, 15 meters, or if it's going to be at 10 meters, for example. I don't know what's going to happen, so I need to compare. Okay? So to know that, to compare, I need to understand that what I'm actually looking for is the delta x, the real delta x, the real distance that the stone covers. Okay, so I'm looking for the real delta x because I don't know if I'm gonna hit the wood piece. Okay, so actually what I'm gonna be looking is the delta x real. I don't know what that is. Okay, so I'm gonna look for it. And you know there's always a mandatory given for this kind of problems, that is gravity negative 9.81 meters over second square. So, as I told you the other day, for this kind of problems, the first step is always to get the components of the initial velocity. So that will be my first step. I'm going to begin right here. Components. Okay? So I know my initial velocity, so I'm going to get my initial velocity in x and also in y. It's going to be the same since I have the angle of 45. So, initial velocity in x is going to be equal to initial velocity cosine of the angle, and initial velocity in y is initial velocity sine of the angle. Apply the formula. So this will be 12 times cosine of 45 and 12 sine of 45. How much do you get from this?
Means always we need to do that process. We have a lunch. Okay.
Yes. How much do you get from this?
8.49.
8.49 rounded.
Degrees.
Meters.
I mean, I rounded from 8.48.
Yes, exactly. That is correct. Now, let's analyze the signs. In x, the stone is moving forward in x, okay? So in x is going to be positive. But in y,
Positive.
exactly. But in y, as you can see, it's going downward. So in y is going to be negative. Do you listen to me, okay?
Yeah.
Okay. So in y, because it's going down, it's going to be negative. So you put the negative sign right here. Okay, negative in y. and the negative right here. That is the first step. Now let's analyze, okay? We're looking for delta x. Now let's analyze the formulas that we have. Now let's see. For delta x, I have this formula, okay? It says that I need initial velocity cosine of the angle and I did the time. Do I have the time?
No.
No, I don't have the time. Because I don't have the time, my purpose is finding the time. Now, let's analyze what equations allow us to use time. Let's see. I find time right here. Time is also included here. Okay. From the equation why am I not gonna be using these equations? Because here the problem is not asking me about x mass or any other thing. Okay, that's why. Though we can get the x max. But anyway, if we get the x max, is not, as you can see, there's no time over there. So even if we use that equation, it's not going to be useful for us. So we can either use this equation or this other equation. Now, which one I suggest to use? Which one do you think is easier to isolate? A or B? The first one. The reason is exactly the A. The reason is because this time is raised to the second power. If it is raised to the second power, we have to use the quadratic formula to isolate the time. It is possible, but it takes longer. So I totally suggest to use A to find the time. Now let's see if we can apply the formula A.
Miss, and with B, supposedly it's going to give us the same.
Yes, both are gonna give you the same, but with the second one, you're gonna take a lot longer. Okay, so we're gonna be using this one. Let's analyze what we have and what we need. I have initial velocity sine of the angle. I have gravity. I'm looking for the time, that's my purpose, but I don't know what the final velocity in y is. So, again, I still can't find the time. So what can I do to get the final velocity?
First, calculate the time.
Take a look. I can't find the time here because I'm missing the final velocity in y. So I have to think. How can I get the final velocity in y? Take a look to the equations that we have.
The one that says dy max.
But we don't know what the y max is. Okay? So if we use this one, we don't know what the y max is and we don't have...
Yeah, but the dy, what it means dy max? The time in y, right?
Yeah, but the time in y max is giving you initial velocity and we know it already. We're looking for final velocity in y. This one is the one that we are looking for. So take a look. If you analyze the rest of the formulas, okay, the only formulas that include the final velocity in y are this one and this one. The others do not include final velocity in y. Analyze. See, and you will notice that there are the only two formulas with final velocity in y. So, I know that I can use the second formula, this other formula, sorry, to get the final velocity in y. Now, let's see if we can actually get it. I know my initial velocity. I know it. Okay? I just got it in the components. I know the gravity, I know it, and I know the delta y. I got it, okay? So, we can use this other formula, the formula, this one. Afterwards, we can use the other formula to isolate for the time. It's a long process, okay? It's a long process, though. You also need to analyze all the possibilities. Now, there are no more possibilities here since the only two formulas that have final velocity in y are those two. If you analyze the rest, you don't have more final velocity, only those two. So that's the only path to follow. So we say in the second step is, you can write the analysis, okay? You can write the analysis as, I need time, I don't have it, so I'm gonna write the analysis later. Because of the time, I cannot take longer, okay? So my purpose is find the final velocity in y to get time. That's my purpose, okay? So I'm gonna use the equation that says final velocity to the second power equals initial velocity to the second power plus twice gravity delta t. Okay? Since I need to get rid of this power, I'm gonna apply square root on both sides of the equation. Okay? So in the end, the formula that I will be using is final velocity in y equals square root of the initial velocity in y to the second power plus twice the gravity time. Sorry, it's not the time, it's delta y, sorry.
Hey, are you writing, Miss? I can't see what you're.
I'm sorry. That stopped. The synchronization stopped. Okay, now it appears. Okay, that's the formula that you have. Now you just place in the givens. Here you need to be a little bit
When we
careful.
use that formula, we should write the square root.
Yes. To find the final velocity in y, get the square root always. Okay? So let's analyze. Initial velocity in y, we have it from here. And it's negative 8.49. But because it's raised to the second power, it's going to give you the same answer. Now it's 2 times gravity times delta y. Now I haven't gotten the delta y yet, but I'm gonna get it here. Delta y is final minus initial, okay? The final position that we got is negative 20 minus the initial position that is 0. So delta y is negative 20 meters. This is important. If you do not include this, then the square root won't be possible. It will be impossible to get. So delta y is actually negative 20 meters. So solve for whatever is in the parentheses in the square root, sorry. How much do you get? I got 464.48 square meters over second square. That's what I got. Then you get the square root of your answer, and you get that the final velocity in y is equal to
21.55.
21.55 meters over second. Now, the velocity in y is going up or down. When the stone hits the wood or the river, is going down or up?
Down.
Down.
It's going down. So here is very important that you place the negative sign over there. Okay? It's very important that you do that. Once you have the final velocity, remember the sketch that we did here, once you have the final velocity, you can isolate for the time with the other formula. So now we say, okay, let's isolate for the time. So the formula that you have for the time is, for final velocity, is final velocity in y equals initial velocity sine of the angle plus gravity time. That's the formula. I will isolate for the time. The isolation for the time with this formula is going to be final velocity in y. I'm gonna leave the isolation here. Delta t equals final velocity in y minus initial velocity sine of the angle divided by gravity. If you need a video on this isolation, I can send it to you. Now, because of the time, I'm not gonna do it, okay? I'm just gonna give you the isolation. Now, substitute by the givens. Final velocity in y, which is negative 21.55 meters per second. This minus is from the formula. The initial velocity sine of the angle is this one, okay? Take a look. Initial velocity sine of the angle gave us negative 8.49. I'm gonna write something here. That is the same initial velocity in y, and we got that is negative 8.49 meters over second. Here is very important that you take good care of the signs. And in the end, you will divide by the gravity, which is also negative 9.81 meters over second square. Now, how are you going to do this? First, solve for whatever you have in the top. How much do you get from there? I got negative 13.06. And I'm dividing by, take a look what I'm doing. I'm taking my time, okay? 9.81 meters over second square. This is working step by step to be sure, okay? What's the time that you got? I got 1.33. Did you get the same?
Yes.
1.33.
1.33. Okay? Now that you have the time, you can get delta x. So that will be the fourth step. Delta x real. So you apply the formula for delta x, that is, delta x is equal to initial velocity cosine of the angle, or VIX times the time, okay? And now you just substitute by the givens. Initial velocity in x, which is 8.49 meters over second, and the time, that is 1.33 seconds. How much is delta x?
11.29 meters per second square.
No, meters. It's x, okay? So, question is, does she hit the... Okay, guys, now we analyze the answers. We got 11.29 meters. Now the question is, does she really hit the block or not? Let's analyze. Let's go back to the image. So the target was placed 13 meters from the bridge. And the real distance covered by the stone was actually just 11.29 meters. In other words, means that the stone just couldn't reach the wood, okay? Because the real delta x is just 11.29 meters. So we answer the question: does she hit the block or no? So we get here and we write an analysis of the answer, and we say we answer the question actually, and we say no, she did not hit the wood block and then you can write the reason: because the target was 13 meters and the rock or the stone only reached 11.29 meters. And with this, we finish with the exercise. I know it is a lot of work, but trust me, if you are careful with the data, if you don't miss any sign, okay, and you don't miss the sign over here too, remember to analyze always where the object is going, then the rest is going to be just fine. It takes very long, I know it, but it's going to be just fine. Thank you guys for your attention.